You might have seen this wind chime recently on Instagram. I rebuilt it in Blender with geometry nodes. The big ring is a simple torus. You can add this primitive from the Add menu. Adjust the main radius and lower the minor radius. I also increase the minor segments to 24 and the major segments to 128. The next step is to model the rotating elements. When I switch to edit mode and deactivate the skin modifier, the simple geometry is revealed. I copied the 5 vertices on one branch of a big circle. Rotate the branch 180 degrees around the y-axis and merge the vertices in the center. After that, I applied a skin and a subdivision surface modifier. Remember, you can scale down vertices in the skin modifier with Ctrl A. The plates are extruded circles. From the standard circle, the first plate is scaled down 0.25, the second 0.2, the third 0.15 and the fourth 0.1. At last I aligned the plates to the curvature. Now let's get to the exciting part, the geometry node graph. When I deactivate the geometry node modifier, you will see that the base object is a simple circle with 16 vertices. Our rotation element is instantiated on each vertex. This happens with the instance on points node. To make the rotation object available, I use the object info node. Without rotation, every rotation object is aligned with the x-axis. We want to achieve that all elements point to the center of a circle. Therefore we need this rotation setup. I need to rotate each object individually. For the first vertex, I need to rotate the element about this angle. The second element about this angle, and so on. We can easily determine the angle. It is the angle between the x-axis and a vector from the center to the according vertex. This happens inside the box. It is the arcus cosine of the dot product divided by the product of length of the vectors. I get the position of each vertex on the circle from the position node. There is no need to create a vector between the center and the vertex because the center is the origin. The vector of the x-axis is 1, 0, 0. The two vectors are plugged into the dot product and divided by the product of the length, and at last into the math node with arcus cosine. The angle is plugged in the rotate Euler node, and without the multiply correction the result looks like this. I set the mode of the rotate Euler node to axis angle so you can get the angle input at the bottom. The rotation axis is the z-axis. During the modeling process, the object lies flat on the ground and the z-axis was the actual rotation axis. Later I parent the object to the torus and rotate it 90 degrees around the x-axis. In the lower half of the circle there is still a problem. The formula of the angle calculates the angle between 0 and 180 degrees. The elements on the lower half require a rotation beyond 180 degrees. We need to correct the rotation for the lower part. I took the position and separated it with the XYZ node and used the Y output. Remember that the object lies flat on the ground and the vertices with negatives Y were the problem. If Y is less than 0, I multiplied it with -1 and adjust the rotation angle. There was still one problem. Without the correction of the correction, it looks like this. Now the upper elements caused the problem. This comes from the less than node. If the condition is false, the result is 0 and the rotation angle for the upper part is also 0. So I needed a case when the result of a less than node is 0, the multiply factor should be 1. The results are combined with the add node. At last the rotation elements should rotate. I use the scene time node and the seconds output. After a few tries I found out that I should multiply the second with 3 and combine the value in the y component of a vector. I added the rotation with the vector add node to our existing rotation. And that's it for the node graph.